Kia ora koutou. This is question 5C from the WC Schol Calc exam this year. This question was really well done by probably about half of you. So lots of people got 4 marks in this question if you spotted how to break down the second part. So let's have a look at it. In the first part, we have to prove that if y is equal to tan inverse of x, then dy by dx is equal to 1 over 1 plus x squared. Now, we had done that in the scholarship sessions and also if you're in 13 MCA. So that part is, I think, a pretty easy 1 mark, and then 2 marks for the next bit. So we've got an art gallery, we've got a picture hanging on a wall 3 meters above an observer's eye point down here at E. Use the result from part 1 to find the distance x from the wall that is going to maximize the viewing angle theta. Okay, so it's an optimization problem, but you're really clearly given a hint to use what we had going in part 1. So let's first crash through the first mark. Where are we? Okay, so we've got y is equal to tan inverse of x, and we don't know how to differentiate that. We're going to rewrite that as something we do know something about, which is that tan of y is equal to x. Now I can differentiate tan of y with respect to y. So we're going to get dx by dy is equal to sec squared of y. And what we have to do is somehow turn this back into something with x. So when you see the sec squared of y, you should think straight away at the stage of the year of the Pythagoras identity, which is that sine squared plus cos squared is equal to 1. So when you see sec squared, you know that we're working with the link between tan squared and sec squared. So we can rewrite sec squared of y as tan squared of y plus 1. Now, tan squared of y is tan of y squared plus 1, and tan of y was x. So we've got x squared plus 1. So dx by dy, which is not what we want, is x squared plus 1, and that's x squared plus 1 over 1. So dy by dx is equal to 1 over 1 plus x squared. Now, if you've somehow, I can't imagine how, but just stumbled on this video and you've not done any work during there on level 3 or scholarship, you'll probably be going, hey, how come we can do this magic thing of actually treating the derivative like a fraction? But you know that we can do that. So that's how we get that one done. So dy by dx is equal to 1 over 1 plus x squared. Right, let's set something up for the second optimization thing. Okay, so we're interested in maximizing theta, and we can see that theta is the difference between this big angle here and this little angle here. So I'm going to call the big angle here alpha and the little angle here beta. Let's just move over, move down to the bottom. I'm going to do some bad triangle drawing now. So we've got the big triangle here, which has got angle alpha. This is length x, this is where the person is standing, and this is 4 meters long, right? 1 for the picture and 3 for the rest. And then we've got the smaller triangle, angle beta is here, x is still here, it's a right angle triangle, and this is length 3. So theta is the difference between those two angles. So theta is equal to alpha minus beta. And now we can just write down some basic facts about alpha and beta. So tan of alpha is equal to, so katoa, 4 over x, and tan of beta is equal to 3 over x. Sorry about the background noise, it's the last day of school and there are lots of noisy year 9s and 10s outside. That means that alpha is equal to tan inverse of 4 over x, which I'll write as 4x to the negative 1. Beta is equal to tan inverse of 3x to the negative 1. That gives me a nice expression that links directly to my hint of theta is equal to the angle whose tan is 4x to the negative 1 minus the smaller one. And we've just learned how to differentiate tan inverse, but some of you completely forgot how to do the chain rule. Definitely something you need to know for both level 3 and scholarship. So now if we go d theta by dx, it's going to be 1 over 1 plus the inside function squared times the derivative of the inside function, which is negative 4x to the negative 2 minus 1 over 1 plus 3 over x squared times negative 3x to the negative 2. Right, so just note in both cases, I'm doing a straightforward achieve level chain rule thing, and I'm using my hint to get the derivative of tan inverse of x. Now, for a maximum, we need to set that equal to 0 for a max. And we've got to do some cleanup. So we've got negative 4 over x squared times 1 plus 16 over x squared plus 3 over x squared 1 plus 9 over x squared equals 0. Right, washing this through, we get negative 4 over x squared plus 16 plus 3 over x squared plus 9 is equal to 0. That gives me 3 over x squared plus 9 is equal to 4 over x squared plus 16. And the rearrange from here, please don't hang up the video, just keep watching so that I can finish the question. 3x squared plus 48 is equal to 4x squared plus 36. And as many of you discovered, that gave us 12 is equal to x squared, and x is equal to the square root of 12 because x must be positive. Now, I can't remember what that is. I think it's 3.4 something. Anyway, equals blah, blah, blah meters. Try to always answer in context and give your units. So that's that one. Well done to those of you who got it all right. I'll gradually work my way through the rest of the paper. If there are any questions you want me to do in a hurry and speed them up the queue, just flick me an email and I'll try and get onto them in the next day or two.